When we talk about agentic systems, we're talking about a new class of intelligent software entities, systems that don't just follow a fixed script, but actively sense, decide, and act on their own. At the core, an agentic system is an autonomous computational entity. That means it observes its environment, whether that's user input, sensor data, or digital content, interpret what's happening, and then uses either predefined objectives or goals it has learned over time to figure out the next best step. And importantly, it doesn't wait for you to manually guide each action. It executes action independently to move towards those goals. Now, this is truly what sets agentic systems apart from the traditional rule based software. Conventional programs behave like tightly scripted actors. If X happens, do Y. Nothing more, nothing less. Agentic systems, on the other hand, operate with flexibility and independence. They can adapt to uncertainty, choose between multiple strategies, and adjust their behavior as conditions change. In short, agentic systems mark a shift from rigid automation to adaptive autonomy, enabling software to behave more like collaborators than tools. To understand how agentic systems actually work in real applications, it helps to visualize what we call the operation canvas. Think of this as the environment or infrastructure an application provides, its services, data sources, APIs, and tools. Agentic systems navigate this canvas intelligently, choosing which resource to use and when based on the context of the problem they're solving. Now, we'll compare this with traditional automation. A traditional script behaves like a straight line flowchart. If a customer submits an inquiry, a script follows a predetermined path, asks a fixed set of questions, returns a fixed set of answers, no matter how unique the situation is. But an agentic AI transforms this experience entirely. It starts by understanding the nuanced queries, even when customer talk about their issues in complex or unclear ways. It can then tap into the knowledge base, internal tools, and business systems such as inventory or order management to gather the information it needs. If something is ambiguous, the agent doesn't get stuck. It asks clarifying questions, just like a human support specialist would. And most importantly, it acts proactively. Instead of waiting for the customer to specify every detail, it can identify issues, surface relevant information, and even anticipate future needs. In essence, agentic systems don't just react, they reason, explore, and resolve. This is what makes them so powerful compared to the traditional rule based script. What actually identifies as an agentic system? What makes it more than just another automated tool? Agentic systems share a set of core characteristics that give them their power and flexibility. The first is autonomy. These systems don't require constant human steering. Once given a goal, they can act independently, making choices and executing tasks on their own. Next is proactiveness. Agentic systems don't just wait for instructions, they can take the initiative. They may start actions early, surface opportunities, or anticipate problems before they occur. At the same time, they are highly reactive. When the environment changes, maybe new data appears, a user clarifies a request, or a system throws an error. They adapt instantly and adjust their behavior accordingly. All of this driven by goal orientation. Whether the goals are predefined or dynamically learned, the system continuously evaluates its choices in terms of how well they move it closer to achieving those objectives. Another defining trait is tool use. Agentic systems can call APIs, query databases, and interact with external services. This ability to leverage tools is what allows them to solve complex real world tasks. They also possess memory, the capacity to maintain context across multiple steps or interactions. This means they don't treat every input as isolated. They build an understanding over time. Finally, agentic systems excel in communication. They interact naturally with users, other software systems, and even other agents, exchanging information to coordinate and complete tasks. Together, these characteristics turn agentic systems into dynamic, adaptive problem solvers capable of operating in rich, unpredictable environments. While agentic systems are powerful, building them comes with a unique set of challenges. These systems don't just execute commands, they think, adapt, and coordinate. And that level of sophistication requires solving several difficult engineering problems. One major challenge is state maintenance. Systems often handle long-running multi-step tasks. To do this effectively, they must remember past choices, track ongoing progress, and maintain context over time. Designing this memory layer, especially when tasks span minutes, hours, or multiple user sessions, is far from trivial. Complexity lies in tools and API selection. Agents may have access to dozens of tools, but knowing which tool to execute, when to use it, and how to call it correctly is a core part of the intelligence. Building that choice making layer requires careful architectures and sometimes learned policies. Then there's agent coordination. In more advanced systems, multiple agents work together, each with its own expertise or role. Ensuring they communicate effectively, share information, avoid conflicts, and collaborate smoothly is a significant design challenge. We must consider resilience and error handling. In the real world, APIs fail, data is missing, and unexpected conditions arise. A robust agentic systems must not only identify when something has gone wrong, but also recover gracefully, retry intelligently, and find alternative solutions without collapsing the entire workflow. In short, implementing agentic systems mean designing for memory, decision making, coordination, and resilience all at once. These challenges are substantial, but solving them unlocks the full potential of adaptive autonomous AI.